Hi, I'm James McGuire, and on today's eSpeaks, we're talking about digital twins and how digital twin technology can help us navigate the many challenges we're having with supply chains. That's a big mess. To discuss that, I'm joined by a major expert in the topic. With me is Dan Mitchell, Global Director of the SAS Retail and CPG practice. Dan, very good to have you with us today.
James, thanks for having me on.
And you're there. I would imagine you're there. I know in Boston. Is it starting to get hot yet in Boston?
I think it's going to be in the 90s this weekend, so summer has arrived finally.
Okay, well, I hope we're ready. So digital twins, fascinating topic. Let's do sort of a level set to start, like define terms. What is a digital twin? I think they come in very handy in the technical world, but explain to us what's a digital twin?
Yeah, a digital twin is, really a digital replica of a real world process or machine. So that can be a machine, that is producing something. Let's say it's on a factory floor and it's, you're creating baked goods and it's creating those baked goods and you have all kinds of sensors tied to it. And you want to actually build a digital replica of that, but it can also be a process that includes many different steps and even people in departments and entities. So that could be your whole supply chain, let's say, all the way from when you buy something from a vendor, it lands in your distribution center, gets broken up into packs, goes onto separate pallets, goes onto trucks, people load those trucks, the trucks go to the store. You could have a digital twin replica of that system also. So really, any real world system that you're building that replica of. And then some things that make it a little bit different. Yes, it's a simulation, but a different approach is that you when you build a digital twin, you model it, you then always try to keep it hydrated with the latest and greatest data. So it's always fresh. It always is mirroring the real world. And then you can reach out and ask it, hey, what's going on right now? And then you can actually run some simulations and other activities around that, which we'll probably discuss a little bit more in depth.
Well,
Um,
there's one part I want to clarify because I might not have been aware of something about that. I think in my mind, when I think about a digital twin, there's a real windmill, say, sitting out there in a field in Holland somewhere, and there's also a digital twin of that windmill on a computer somewhere in Holland, but they're not connected at all. But the digital model does say like how many miles per hour of wind that windmill can handle. But you're saying, are they actually typically literally connected with sensors?
it doesn't need to be, but ideally it should. So one, you can take all that sensor data, train your model, and you're right, you can run it in isolation and use that to do simulations, or you can use it to optimize the system, or you can keep it tethered live to that sensor data. I mean, that's the beauty of IoT, cloud, and sensor data is you can keep, like I said, I use the term hydrated.
Right, I
You
like
keep
that
that
term.
twin always up to date with what's going on. And then some people will even put control towers on top of that to monitor and alert them.
I would guess, and not to get too far down the rabbit hole, but I would guess at some point in the future, the idea of a digital twin that's completely in isolation to its physical real world is going to be somewhat obsolete. We're going to need a sensor tracking system to be a really valid digital twin, correct or not necessarily?
I think it seems like it'd be easier that way, right? And I think when we talk a little bit more about what we've seen with the supply chain, I think there's some good use cases in there. Another thing, I guess to that end, think about when you use the Waze driving app, right?
Right, right.
All the power that it has in that. Now, at first, it was, wow, I have a map, I can get to where I want to go. It's on my phone. That's fantastic. And it collected all the highways and routes and exits, and you could put in this, where you want to start and where your destination is, and it would tell you how to get there. Then it started to do simulations to say, well, here's 3 ways to get there, and you pick which one you'd like. Do you want to pay tolls or not? Do you want to get there as faster? Do you want to avoid urban areas, let's say? So there was
Mhm.
some capability. But
Hmm.
really, the big unlock became when the data inside of that application is live. So when you pick up your phone right now and you pick a route, it actually tells you how long it's going to take you to get there based on the traffic patterns that are happening right now, as well as all the traffic patterns in the last 3 or 4 weeks.
Hmm.
It gives you that information. I guess I'd even take it a step further. The way I use Waze often is I will put in what time I want to get there.
Hmm.
What time do I want to get to Logan International Airport?
Hmm.
And then it will tell me what time I should leave. So
Hmm.
I actually change my plans based on running a simulation of how long it will get there. That's really the same capabilities that everyone's going after when they use digital twins these days.
Hmm. Interesting. So, all right, let's take a look at what trends you see driving the development of digital twins, and I mean, in the larger sense, how can digital twins help us with the supply chain challenges?
Okay. Um, I think the there's just been a lot of disruptions over the last couple of years
Right.
uh, that have taught us so many lessons about our ability to predict what's going to happen next.
Mm-hmm.
Meaning, none of us would give ourselves a great score, but again, I think we're scoring on a curve here. So to be fair, we also learned a lot about how one change on one side of the supply chain affects the other end of the supply chain.
Hmm.
And sometimes it's a straight line, sometimes it's exponential, sometimes it happens instantly, other times it's a slow build to a point where a problem builds up so much that a bubble sort of bursts and everything comes to a grinding halt. So, I think we learned a lot of lessons there, and I think that's really prompted people for look for a better solve.
Hmm.
The other thing that is a shift is that we were very comfortable predicting the future by using historical data.
Right.
That's what we all did: sales data, inventory data, whatnot. Now, that data is, for all intents and purposes, corrupt.
Hmm.
Um, you
Like
know,
past returns do not predict future performance.
Absolutely not, right? And so if I go back and look at some of my historical sales data or inventory data, I might see a huge spike. Um, was that because people were really interested in buying my super awesome product? Or it might have just been when it became available on the shelf and they were waiting for it for days or weeks.
Hmm.
Or maybe it was a panic buy. And it has nothing to do with the wonderful promotion that I ran.
Hmm.
So, I think that's a good, if you go back and look at that problem, we don't have that data. We need to come up with a better answer. We need to either find other data sources that are a surrogate for demand or predicting what will happen of inventory flow. I heard someone make this joke a couple of weeks ago that the most popular promotion out there right now is in stock. So,
In
if
other
the
words, I can
item's in
actually get my
stock,
hands on it.
yeah, well, and at first it's funny, yeah, like, hey, yeah, that is funny. But well, when it is in stock, I need to let people know
Hmm.
immediately. Forget about running a promotion that I'm discounting something. People want to know what if it's in stock on the shelf, so they can get in their car and drive down the street or hop on a website and order it. Um, when I talk to customers today, they say to me that same thing. I don't need any technology from you to help stimulate demand, right?
Hmm.
What I need help with is really dialing in exactly when I will have the inventory available in front of the customer. Because a lot of things happening when I'm producing the products or sourcing the products that affect when it's available. So labor shortages, ability to source ingredients, let's say,
Hmm.
labor shortages on the factory floor to retool some equipment that's manufacturing something,
Hmm.
labor shortages in the DC, or even, frankly, someone to drive the truck. It's one thing to get all the boxes in the truck, then you need someone to drive it, where there's significant shortages there. So being able to accurately simulate, what will happen next in that scenario, and being able to tie that to the on-shelf availability and make decisions that in the end are giving us that highest service level is really the game afoot right now.
Hmm. All right. So, what advice would you give companies in getting started with digital twins or managing their existing deployment? I mean, I know there's a lot of challenges out there. How do they handle those challenges?
I guess I would say in the getting started, we have a pretty exhaustive template framework that we use to help people get started and get their arms around, what they're about to build or what they want to build.
Hmm.
Um, but just like 3 or 4 highlights out of that. You really want to do an assessment of do you have all the data to build this twin?
Mhm.
And the quality of it. And do you even own it? Who owns it? Do I need to pick
Right.
up the phone? How am I going to get that information? Or you might need to even invest or buy data. So you might need to go down that path too. The other thing that you really need to understand is what parts of the business that the digital twin might touch. Who are all the important stakeholders that are involved in this? And that might not be so obvious. You might think it's this entity, that entity, and then someone says, well, what about the website? Oh, heck, we didn't even think about that. Or what about our vendor? Or what about a supplier? And then I think probably the last thing, big things that can be, a showstopper is, do you actually have the ability to take action on the results of that simulation? Can you change something? If the simulation says do this, are you actually able to make that change? Can the business make that change? Can you change the number of orders from 10,000 to 5,000? Maybe the vendor says, no way, I can't do that. Or the other flip side of the coin is, does the company have the ability to monetize the output of that, right? Can we actually capitalize on that?
Mhm.
Can we make the investments to make that change? Those kinds of things. Do we need to buy new sensors? Can we make those investments? So
Mhm.
some things to think about there. And then once you have it up and running, I think there's just a little bit of discipline, just like, the term DevOps, right?
Right.
That you have dev operations. We have a term here at SAS that we call model operations.
Hmm.
So, when I build a model and how do I push it into production? How do I then monitor it? How do I version control it? When do I get alerted when it drifts and starts to become less accurate? Those tools are really important to guarantees for success.
Hmm. All right, let's drill down into SAS itself. I mean, how is SAS addressing the digital twin needs of its clients? I mean, why would a company choose SAS? What's the advantage?
Sure. We've been in the analytics business, for over 45 years. We pretty much have every analytic technique, tool you might ever need to solve for a problem.
Mhm.
Also because we've also played across many different industries. So, we picked up a lot of the needs of the market, the sophisticated, inventions from, many folks around the world. And we really have the ability also to ingest any data source.
Hmm.
And that really, becomes really key when you start to build these complex systems. You don't want to have a whole hodgepodge of different things, connectors together to source and bring that data together. And we also have analytic tools that are much more drag and drop, right? So you can throw your data in the SAS system, start modeling on it. We'll actually make suggestions to you, different techniques to use. We can even blend together many different analytic techniques. And really, that is really the state of the state. When you have all these different types of data sources, whether it's structured, unstructured, streaming, text data, what have you, machine data, you
Mhm.
need to use a whole bunch of different techniques. And so we can even blend together an ensemble of those models and pack them up and then put them into production. So being able to use sort of every technique that you want to bring to bear, but not have to code that. So in a low code, no code capability. And I guess the other thing too, I guess what I would kind of call on is our experience in this area. We've been working on simulations for many years. We have one of the largest CPG companies in the world. They use simulation that we've built to formulate how their different formulation of some of their detergents. And so when they want to make a change to a dye or a chemical, or how much a chemical costs, they can run the simulation in the computer and then turn around and direct the factory floor what to do.
Hmm.
And we have another company that you might recognize is Georgia Pacific. We've
Sure.
been doing work with them around IoT, around quality and optimization of some of their manufacturing lines for paper goods. And there was a lot of action on paper goods in the last
Mhm.
couple of years also.
Definitely.
And that's just a lot of data streaming off of those devices on those production lines, and our ability to do intelligent filtering and kind of pack that down and take the streaming data and turn it into information is really key.
Hmm.
And then, it kind of goes beyond that. I'm in the retail and consumer goods package group. We have purpose-built solutions that solve for price optimization, inventory optimization, demand planning and forecasting, even customer segmentation, web personalization, all of those things. And because it's on this one SaaS platform, it then creates like an ecosystem where we can connect all these applications. We can pull data from all of these different business plans, pass it to the digital twin, run the simulation, and then get the answer and put it back into the business planning processes. Something that really no one else has out there. And that also opens up the opportunity for other partners to come into this ecosystem also. A couple of weeks ago, we announced a partnership with a company called Cosmotech. And they're really, a premier player in this digital twin space. They have a lot of experience. And because we have this open system, we can partner with them and they can connect their digital twin capabilities and technology and even their cloud directly into our platform, and allows us to get off to the races really quick.
All right, let's look to the future of digital twins. It seems like there's a lot going on and a lot of potential, especially since we have IoT and edge computing. I'm sure that's going to play a role in the future of digital twins. What do you see as some key milestones we can expect in the years ahead? What's coming? What should we know about?
Yeah, I mean, I guess I have a keen interest in the area of kind of where the adoption is going to track, especially from a supply chain perspective. I see that it would just be a massive increase in the people using digital twins to solve for and tease out risk of systems and supply chain. So it's one thing to make it better, faster, stronger, right? But I think there's a whole, everyone's woken up to what risks do we have in our operational systems, and being in really the increase of this whole domain of creating synthetic data will really be a fuel into this pump. So if I can create massive amounts of synthetic data of all kinds of possible things that could happen in the real world, pump them into my digital twin, see where the bottlenecks happen, see where the wheels come off the bus, where the leaks occur. Then I can go back in and digitally create a new version of a system, prove that it works, and then turn around and implement that in the real world and take the risk out of what's going on. So I think that's one big area where I think we'll just see more and more stories of success around that. And I think the other area that I'm kind of excited about, especially in retail and CPG, the whole supply chain has a significant carbon footprint.
Very much so. Right.
Anytime we buy something, sell something, one small decision about what to sell, where, and when can have a huge impact on sustainability and consumption.
Sure.
So I'm excited to see more and more ESG goals get put into my digital twin. So not just margin and service level and cost, but my sustainability goals on power, water. And I think the other thing that I'm excited about, and maybe it's a little altruistic, but there's a lot of humans in the supply chain who are making it work every day at every single node. And there's a huge opportunity to make their jobs better and make their job safer, make their lives better. So I know that's a little out there.
More efficient? Is it safer and more efficient? How does it make their lives better?
I mean, I think if a given process was running smoothly and we would need to make less changes to it because we've perfected it, if we've understood by putting X number of more machines working along X number of folks, and we've learned from our mistakes in the past, I think, and be able to run simulations of different system changes before we implement them. I think in the end, it will just, have a lot more predictability, reliability of those systems in place. And again, just makes it easier to work alongside of some of these machines. Not just not always throwing more machines at the problem isn't going to, is always the answer too.
Dan, I think you said it. Fascinating stuff. It's going to be an interesting sector to watch in the years ahead. Thanks so much for sharing your expertise today.
All right. Well, thanks for having me.